Hello everyone, our topic for today is about polynomial functions. So what's up for today? So today we will be discussing polynomial function, and as we go along, you would be able to illustrate polynomial function. Before we start on our main topic, let's have a review. Remember that a polynomial is a special type of mathematical expression. These are the things to consider in determining a polynomial expression. Polynomials cannot contain variable exponents. They also cannot contain non-integer exponents. In general, polynomials can contain fractions. However, they cannot contain variables in a denominator. Polynomials cannot have negative exponents on variables. Polynomial is an important part of the language of mathematics and algebra. They are used in nearly every field of mathematics to express numbers as a result of mathematical operations. Many mathematical processes that are done in everyday life can be interpreted as polynomials. For example, summing the cost of items on a grocery bill. A polynomial function is a mathematical expression represented by variables, constants, and the mathematical operations performed on them. It is a function of the form p of x equals a sub n times x raised to n plus a sub n minus 1 times x raised to n minus 1 plus a sub n minus 2 times x raised to n minus 2 plus plus a sub 1 times x plus a sub 0, where a sub n should not be equal to 0, n is a non-negative integer, a sub 0, a sub 1, to a sub n, or the a sub i's are real numbers called coefficients. A sub n times x raised to n is the leading term, a sub n is the leading coefficient, and a sub 0 is the constant term. The terms of a polynomial may be written in any order. However, if they are written in decreasing powers of x, we say the polynomial function is in standard form. Look at the sample below. Other than p of x, a polynomial function may also be denoted by f of x. Now let us identify the degree of the polynomial, leading coefficient, and constant term. Our polynomial function is p of x equals 3 times x raised to 4 plus x cubed plus 2x squared plus x plus 7. Take note, the degree of the polynomial is the highest exponent, denoted by n. The leading coefficient is the coefficient of the term bearing the degree of the polynomial. The constant term is the last term, or the term with no variable. Now let us determine the degree of our polynomial function. In our polynomial function p of x, we have the following exponents: 4, 3, 2, and 1. Among these exponents, the highest is 4. Thus, p of x is in the 4th degree.
Now, we are going to identify the leading coefficient of the polynomial function p of x. We have already identified the degree of our polynomial, which is 4. So, the next thing to do is to look at the numerical coefficient of the term bearing the degree of the polynomial. In this case, it is 3. Hence, the leading coefficient of our polynomial function is 3. Lastly, we are going to identify our constant term. As you can see, our polynomial function is already in standard form. So, our constant term is 7.
Now let us complete the table below. Our given polynomial is p of x equals 3x cubed minus 2x plus x raised to 5 minus 7 plus x squared. To rewrite our polynomial function in standard form, we are going to arrange our terms in decreasing powers of x. Since x raised to 5 has the highest exponent, it will be written first, followed by 3x cubed plus x squared minus 2x minus 7. Since the highest exponent of our polynomial function is 5, then our polynomial function is on the 5th degree. The leading coefficient of our polynomial function is 1, and the constant term is negative 7. Here's another example. Our given polynomial is p of x equals 2 times x raised to 4 plus x raised to 7 minus 2x plus 6 times x raised to 10 plus 2 minus x squared. The standard form of our polynomial p of x is equal to 6x raised to 10 plus x raised to 7 plus 2x raised to 4 minus x squared minus 2x plus 2. Since the highest exponent of our polynomial function is 10, then our polynomial function p of x is in the 10th degree. Our leading coefficient is 6, and our constant term is 2. Now let's try this. Complete the table below. I will give you 1 minute to apply what you have learned. You may pause the video if you need extra time to work on the task. Your time starts now. Now let us check your answer by comparing it to mine and see if you got it right. The standard form of our polynomial function is p of x equals x raised to 9 plus 2 times x raised to 7 plus 3 times x raised to 4 minus x squared minus 7x plus 11. Degree of our polynomial function is 9, and coefficient is 1, the constant term is 11. Let's have another example. I will give you again 1 minute to apply what you have learned. You may pause the video if you need extra time to work on the task. Your time starts now. Again, let us check your answer by comparing it to mine and see if you got it right. The standard form of our polynomial function p of x is negative x raised to 14 plus 12 times x raised to 7 plus x cubed minus 2x squared minus 5x. The degree of our polynomial function is 14, the leading coefficient is negative 1, and our constant term is 0. Now it's time for you to work alone. Answer the given problem independently to assess your learning. You may pause the video for you to have more time to work on the task. Problem set. Rewrite the given polynomial function in standard form and identify the degree of polynomial, leading coefficient, and constant term. Number 1. P of x equals 3 times x raised to 4 minus 2 times x raised to 6 plus x squared minus x plus 12. Number 2. P of x equals x squared plus 2 times x raised to 5 minus 3. Number 3. P of x equals 5 times x raised to 9 minus 2 times x raised to 5 minus 3x cubed plus 23. Thank you for watching our video lesson for today. See you in the next video. This is Teacher Mabi signing off.